GCSE Physics boosters, and this video is about orbital motion. So to help us understand it, imagine there's a cannon on a hill at the North Pole. Okay, doesn't have to be at the North Pole, could be anywhere on the Earth, but there's a cannon on a hill and it fires a cannonball horizontally, and the cannonball is going to follow a path like this. It'll come out of the cannon horizontally, then it will fall towards the Earth and it will blow somebody up somewhere. Now, what difference would it make if we use more gunpowder? Well, if we use more gunpowder, the cannonball will have more kinetic energy, so it will travel faster, so it will spend more time in the air, so it will travel further, so it will blow up somebody in another country. Let's use even more gunpowder. Let's go crazy. So the cannonball travels even faster and it goes even further. Now notice now the cannonball is starting to follow the curvature of the Earth. So as the cannonball falls towards the Earth is curving underneath it, but still it goes a long way and then crashes into Earth. Do you know what? Let's use even more gunpowder. And can you figure out what's going to happen if we use enough gunpowder? Then the cannonball will go all the way around the Earth. Okay, it's falling towards the Earth all of the time. Okay, but because the surface of the Earth is curved, if it's traveling at just the right speed, it will never hit the Earth. It will go into orbit. It will orbit the Earth. Ignoring air resistance, to do this, it would have to be traveling at about 8 kilometers a second, and it would take about 88 minutes to go all the way around the Earth. Okay, but it's constantly falling towards the Earth, but not getting any closer to the Earth. Now, this idea of the cannonball is actually Isaac Newton's, and this is from one of his books, from one of his Principia books, and it's exactly the same argument as I've just given you now. Now, for our cannonball to stay in orbit above the Earth, it would have to be above the Earth's atmosphere. Why? Well, I've already mentioned, basically, air resistance would slow it down. If you're above the Earth's atmosphere, and remember, you only have to go up about 100 kilometers to get above the Earth's atmosphere, then the cannonball isn't going to slow down, and it will go round and round the Earth for a long time. There are lots of satellites up there, lots of man-made satellites. We say man-made, an awful lot of women help to make them as well, but lots of man-made satellites, over 19,000 of them at the moment. They're used for GPS, communications, weather, astronomy. There's the International Space Station, military, like spying, looking at the Earth. Lots of other uses. There's lots and lots of satellites. Okay. Now, the Earth has a natural satellite, which is the Moon. The Moon has been going around the Earth for about 4 billion years. Okay, so that is a natural satellite. And the Earth is a satellite of the Sun. The Earth and all the other planets and everything else in the solar system is all going around the Sun. Remember this sentence here: gravity provides the force that allows satellites and planets to maintain their circular orbits. If you're going to learn something word for word to chuck out in an exam, learn that sentence. It's gravity. Gravity keeps things in orbit. If gravity wasn't there, it wouldn't stay in orbit. A few other things about satellites. So the object which is in orbit is accelerating due to gravity. It's falling towards the Earth. Okay. The speed of the object isn't changing, but its velocity is. and acceleration is change in velocity over time. So if its velocity is changing, then it's accelerating. Okay, we say that its acceleration is centripetal. It means it's towards the center. Astronauts, these astronauts are floating around and doing crazy things and bouncing off the ceiling, and they look as though they are weightless, but they are not weightless. Okay, it's just that they are falling, the space station is falling, and they are falling with the space station. Okay, it's imagine you're in a lift and somebody cuts the cord in the lift and everything is falling. So a camera inside the lift would see you floating around as well. You know, they are falling and the space station is falling with them with the same acceleration. Lastly, one last thing that we need to know. To be in a stable orbit at any particular radius, the satellite has to be traveling at a certain speed. So for a close orbit around the Earth, about 8 kilometers a second. As you move further away from the Earth, to be in a stable orbit, notice that the speed changes. As you move further away from the Earth, the speed actually gets less, the speed needed for a stable orbit. If you think about the planets going around the sun, Mercury goes around the sun in about 80-something days because it's traveling very, very fast. And it doesn't have very far to go, whereas something like Pluto takes like a couple of 100 years to orbit the sun. Okay, because it has a long way to go, and also because it's not traveling very fast at that radius. A guy called Kepler figured all that out.